Lewis structure can be written following these steps. We're going to see a couple of examples today. The first example is hydronium ion, H3O+. Step 1. When you have a molecule, you need to first place the atoms relative to each other. General rule of thumb, put the least electronegative atoms in the center. In organic chemistry, carbon, nitrogen, oxygen are often the central atoms. Hydrogen and halogens are often the surrounding atoms. For hydronium ion, 3 hydrogen and 1 oxygen form this cation. Oxygen is obviously the central atom. We could also put the surrounding atoms and keep in mind that Mother Nature likes symmetry. That's our step 1. For step 2, you need to determine the total number of valence electrons available. Hydrogen has 1 valence electron. For 3 hydrogens, that's 3. Oxygen is group 16 elements, has 6 electrons, therefore totally 9 valence electrons. That's for neutral compound. For ions, depends on if it is cation or anion, you need to either subtract or add electrons for each charge. For hydronium ion, you need to subtract 1 electron. Therefore, there are totally 8 electrons. That's step 2. For step 3, you're going to draw a single bond from each surrounding atom to the central atom and bookkeeping the electrons. 3 sigma bonds, and each have 2 electrons. Therefore, we used up 6 electrons. Now, there are only 2 electrons left. That's our step 3. Step 4 describes how to distribute the remaining electrons. Usually, you would distribute them in pairs, and you also typically put lone pairs on the surrounding atoms first, followed by the central atoms. For hydronium ion, again, hydrogen would only form 1 bond. Therefore, this pair of electrons will have to come to the orbital of the oxygen. That's step 4. Step 5, if your central atom is short of electrons, doesn't have 8 electrons surrounding it, doesn't have the octet, you need to add multiple bonds to complete octet. For this case, the oxygen has 8 electrons surrounding it, so we could skip to step 6. We're going to see examples of multiple bonds later. Step 6 is to ask you include formal charges. Formal charges are not actual charge, but it's a way to bookkeeping electrons. Formal charges can be calculated by the number of valence electrons of each individual atom minus how many electrons are assigned to this atom. For this case, for oxygen, number of valence electrons is 6, number of bonds is 3, and number of non-bonding electrons are 2, so calculated out it's a positive 1. In this case, oxygen has a positive formal charge. So, once you have a Lewis structure written, you could check on your structure. For instance, you could look for the atoms, see if each of them have octet. And the other way to check is to check on formal charges. The formal charges for each individual atom should add up equals the overall charge of the ion. If you have a neutral compound, the formal charge should add up equals 0. And this is how we draw a Lewis structure of hydronium ion. I will show you more examples in a later video.